Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of constants, specifically how we can find constants in tables, and we'll do it in 5 minutes or less. So we have a basic input-output table here, something we've been looking at for multiple years, and in the past when we would get something like this, we would typically try to find the rule. What are you going to multiply by, or what are you going to add to x to get over to y? And then we would have to identify whether it's an additive relationship, that means we are adding, or is it a multiplicative relationship? We are multiplying something to that x to get to the y. Well, we can do the same thing in 7th grade, but we're going to use slightly different terminology. We are going to look for the constant of proportionality. And that's something that we are working a lot with in our 7th grade. And if we look at our math chart for STAR, we'll see that we represent our constant of proportionality with K. And it says K equals Y over X. So the constant of proportionality is when you get an x and a y variable and you put the y over the x. Well, let's see if that works here for our table. So k equals, and I could just write a whole series of equivalent fractions, right? Y over x, 21 over 3, or 35 over 5, so on and so forth. And hopefully, if you know your multiplication facts, you're thinking to yourself, well, that's easy. That's 7. Which, if you're thinking 7, you are correct. So that's also what we've been figuring out for years. We would just call it the rule. So when you have a multiplication rule times 7, that's actually the constant of proportionality. We would multiply each of these x's to get to 7, from 7 over to that y value. That's our constant of proportionality. So k equals 7, and it only works when we have a multiplicative relationship. Doesn't work when we have an additive relationship. So we can say our constant is 7 because we multiply the x values by 7 to get to the y values. And that's also our rule. Now, what happens when you're going from x to y and the numbers are getting smaller? Well, here's another table. You notice I've shifted the x and the y values, and they're getting smaller. From x to y, we're getting smaller. And once again, if we were to think of this as our input-output table, we would think of what is that rule? And if they're getting smaller, we're either subtracting something or we're dividing by something. But let's think about it in our terms of constant of proportionality. So our constant is going to be x dividing into y. So if we were dividing that x up into y, or we can think of it as y over x, what would we get? Well, let's see. Well, it's going to look a little bit backwards, right? Because the y is actually our numerator. So it's going to be a fraction, right? But it's going to be a fraction that we can simplify. That x is going to be 25. That's going to divide up into my y of 5. Same with this 15. That 15 is dividing up into 3. Now, here's what's interesting is I've got, look at that bottom one, right? I've got a 1 over 5. And then I've got a 1/5 actually as a numerator, right, over my 1. What happens when you have fraction in your numerator? Well, it actually just ends up flipping, going like that, flipping upside down, and it becomes 1 over 5 over 1, which is just 5. You end up inverting it and then putting it in the denominator, which hopefully you notice all of these are equal to 1/5. So they actually give it to you right here and right here if you think about it. Now, how do we write that as a rule? If our k is 1/5, well, we could say you divide by 5, but when we're writing our constant, we're not going to write it as a division problem. We're going to use the inverse, right? The reciprocal. And so dividing by 5 is the same thing as multiplying by 1/5. We learned that in 6th grade. So our constant of proportionality is 1/5, because if you multiply each x by 1/5, you get the y.